Hello, everyone. Today, let's explore a super fascinating and surprising topic. Why are more and more scientists convinced that extraterrestrial life exists, and why might it be completely different from anything we can imagine? We're all familiar with life on Earth, from the smallest bacteria to the giant blue whale to ourselves. We all share one ID card. We are carbon-based life. Carbon is the ultimate all-purpose framework for the building of life. It easily links with other elements to create complex structures like DNA and proteins. On Earth, a greenhouse with stable temperatures and abundant water, carbon-based life is indeed living very comfortably. But here's the problem. In this vast universe, 13.8 billion years old and 93 billion light-years across, is Earth the only place life is sparked? In the cosmos, Earth-like greenhouses are probably painfully rare. Instead, the universe is filled with countless extreme environments, high temperatures, immense pressures, strong acids, or endless frozen wastes. If we keep insisting on using our carbon-based key to unlock every door to life in the universe, that is, frankly, an incredibly foolish move. With ongoing experiments, scientists are gathering data that reveals life could be thriving in ways you cannot imagine, sprouting wildly in any corner of the cosmos. First, let's not rule out other Earth-like planets with carbon-based life, but their form could completely overturn our perceptions. Even a slight change in environmental conditions can produce radically different life forms. The most important point is gravity. According to simulations, if we lived on a planet with just slightly more gravity, all the blood in our bodies would be forced to our legs, our bones would constantly shatter, and our entire bodies would be crushed flat. However, for carbon-based life on that planet, after billions of years, they might evolve thick, sturdy exoskeletons and massive limbs to support their weight, compensating for the constant downward pressure. Or, to escape the high gravity, they might live permanently underground, evolving into flat ground-crawling forms or deep burrowing creatures. Now imagine a low-gravity planet, a place where creatures could jump hundreds of meters or even fly without wings. They might evolve into giants, with light bodies and long, slender limbs, moving freely like ghosts in the wind. But if gravity is too low, they'd face another problem. Their bodies might easily disperse. So perhaps they'd evolve adhesive, sticky forms, like giant, deeply rooted trees, or creatures that float in a dense atmosphere. Pressure is another key. On Earth, our stable atmosphere supports life, but in the universe, some planets have pressures thousands of times higher. Creatures there would need super hard shells to resist being crushed, or live inside internal gas pockets for balance. Conversely, in a near vacuum, life might take on crystal or plasma forms, needing no air to breathe, only energy from cosmic radiation. And temperature is another challenge. On scorching hot planets like Venus, with an average temperature of 460 degrees Celsius, carbon-based life is impossible. But you might find sulfur-based life, where chemical reactions happen in liquid sulfuric acid instead of water. Scientists have simulated that at extreme heat, proteins could be replaced by more stable silicon polymers, creating creatures like metal insects crawling on a hellish surface. And in icy places like Europa, Jupiter's moon, with a deep ocean hidden under kilometers of ice, life might be based on liquid ammonia instead of water, with a metabolism that is slow but stable for millions of years. And what about light? On Earth, life depends on photosynthesis, but on rogue planets with no parent star, organisms might use chemosynthesis, drawing energy from the chemical reactions of rocks and gas, just like the bacteria in our own deep-sea hydrothermal vents. Or on planets near a neutron star, organisms might eat gamma rays instead of organic food. All of this shows that life is not bound by the earthly formula. Scientists estimate our galaxy alone has hundreds of billions of potentially life-supporting planets. If we keep limiting our search to carbon, we will miss almost all of them. Now let's think bigger. What if life isn't based on carbon at all? Carbon is great, but silicon, its brother, right below it on the periodic table, can do many of the same things. Silicon forms strong bonds. On hot, rocky planets, you could have silicon-based life. Imagine creatures like trees, but made of rock, breathing oxygen and eating silicon dioxide to build their shells. They might live for thousands of years, with a metabolism that thrives at temperatures carbon can't handle. On Jupiter, with its immense pressure, perhaps there are ammonia-based floaters, their bodies suspended in the dense atmosphere, drinking ammonia rain and eating hydrogen gas. They live like giant balloons, with their brains distributed in a gaseous shell. Or on Titan, Saturn's moon, with its lakes of liquid methane, life could be based on hydrocarbons. Water is methane, and creatures are like worms swimming in a sea of oil, metabolizing at minus 180 degrees Celsius. In even stranger forms, think of crystal-based silicon life. Sentient rocks growing from a silicon desert, communicating via vibrations or electromagnetic pulses. They might grow branches to explore, with lifespans of millions of years. Or organisms based on boron nitride, on highly acidic planets, forming corrosion-proof shells and living in streams of sulfuric acid as fish live in water. NASA scientists have simulated this, showing that boron nitride molecules can form helical structures just like DNA. And then there is life not based on familiar chemistry at all. Plasma-based life, made of ionized gas at thousands of degrees. In labs, physicists have created self-organizing plasma spirals that can divide and replicate. These plasma clouds evolved, preserving the most stable copies. Perhaps in the sun's corona, or in the atmosphere of a neutron star, living plasma clouds exist, but because nuclear reactions replace chemical ones, their entire lives might last only a few minutes, a whole generation, born, evolving, and dying in the blink of an eye. Now think in reverse. What if we are the bacteria? What if there are organisms as large as galaxies, or even the universe itself? Life doesn't have to be based on atoms. It could be interwoven with the complex structure of the cosmos itself. Life could be everywhere. So back to the original question. Does extraterrestrial life exist? If we draw a circle with Earth at the center and carbon as the radius, we will probably only find ourselves. But if we dare to pick up an unconventional pen, like silicon or plasma, a breathtaking, infinite canvas of possibilities opens up before us, a kaleidoscope of cosmic life. Diatoms, those beautiful silicon-shelled algae on Earth, remind us that life never traps itself in one box. What we are looking for is probably not an Earth brother. We are looking for a thinking stone, a glowing crystal in a methane sea, or a cloud of energy singing in a stellar storm. They are interpreting the miracle of existence in a way we just don't understand yet. And you and I, we are part of that miracle, and we are the ones opening the next door. See you all in the next video. Remember to like and share, and let's keep exploring the mysteries of the universe together.